Here us to multiply the following rational expressions and list the excluded values. So first of all, to multiply, I'm basically just multiplying straight across, right? So I'm multiplying x plus 2 times all of this. I'm multiplying x squared plus 12x plus 36 by all of this, like straight across. And so when I do this, basically I want to kind of get rid of this multiplication sign and kind of just put them together, right? Because I can just put it all into one fraction bar and then say I'm multiplying everything on the top and multiplying everything on the bottom. But the way we multiply, it's great that we can do that and we can just rewrite this, but we want to see if there's anything that we can simplify. And so to do that, we're going to need to factor. And so basically, I'm going to take a second here to factor every polynomial that I can, which is those three things that I underlined. I'll do it on the side here and kind of speed it up so you don't have to just sit there watching me, do a diamond in box 3 times in a row. Okay, so I've now factored all three of these things. I'm going to rewrite my original equation now, all put together, and then we'll see what we can cancel. And so it starts off with x plus 2 on the top. And then my first one that I factored here, let me change colors here, a little orange. What I factored here is what I got from this. So we have x plus 6 times x minus 2. And then our second one here, we have, what is that, x, this one right here became this. So now we have over x plus 6 times x plus 6. And then this right here in the denominator, I factored here. And so I got x plus 2 and x plus 3. So, okay, just to clear this up a little bit, we have all the ways that I factored. Now I'm going to kind of show us right next to each other what we ended up getting. So we got all of this is really what we originally started with, just factored, right? So you can see the top, originally we had an x and an x squared equation, which is why we got 3 x's. This one we had an x squared times an x squared, which is why we got 4 x's all the way factored out here. So it's good that we have all this. What we need to kind of do now is, I personally like to rearrange them just to show the giant one principle. And so when I do this, we'll rewrite this here in purple. I'm going to put anything that matches itself on top of each other, right? So I have an x plus 2 over an x plus 2. I have an x plus 6 over an x plus 6. And this x minus 2 on the top doesn't match up with anything else, so I just have to make sure I have everything else on the bottom here. And so the reason I can rearrange that is because multiplication, the order doesn't matter. If I do 2 times 3 or 3 times 2, I still get 6. But now I can see that if I'm dividing these two things, x plus 2 divided by itself is just 1. X plus 6 divided by itself is also just 1. And so 1 times anything is just that thing. So I can kind of simplify this down to x minus 2 over x plus 6 times x plus 3. And then I personally think that simplifying and putting it in standard form is best. So I'm going to multiply this out together, x plus 6 times x plus 3, which would end up giving us x squared plus 9x plus 18. And this is my final answer after canceling as much as I can. So that's our multiplication. Let's repeat it for the second one here. Again, I'm going to go a little bit faster on the factoring, not to waste any time. So on the top here, I got 2 times x plus 1 because I factored out the 2. On the second part here, I have x times x minus 4 because I factored out the x. I'll put all the pieces here in parentheses so that I can help rearrange that later. The bottom here, if I were to factor this, it would become x minus 4 and x plus 2. If I were to factor this, I'd get x plus 1, x plus 1. And I'm just trying to save some time by not doing the factoring on the video. So if you need to practice factoring, I would do that in another spot. So now I'm just going to rearrange this stuff, right? So I'm going to put the 2 and the x together here on the top. I'm going to put the x minus 4 over the x minus 4. I'm going to put the x plus 1 over the x plus 1. And then that's everything in the numerator, but in the denominator, I still have an x plus 2 and another x plus 1. So now, when I'm doing this, I see that there are 2 giant 1s because anything divided by itself is just 1. And 1 I don't need to include in a multiplication problem because 1 times anything is just that thing. So then this most simplified version here, so I got 2x over x plus 2 times x plus 1. And then I will multiply that denominator back together to get x squared plus 3x plus 2. And that is how I multiply. So multiplying straight across, factoring everything as much as I can so that I can use that giant 1 principle to cancel out anything and leave me with my simplified answer. Make sure on these problems you're also listing the excluded values, which in my final 2 problems here is basically just anything that would make the denominator 0, right? So when I look at the expanded form of each of them, basically anything that would make any of these little parentheses 0. So can't be -2, can't be -6, and can't be -3 for the first one. Whereas on the last one, in the broken down form, x cannot be 4, x cannot be -1, and x cannot be -2. Those are all the excluded values because I can't have a denominator that is 0.